There are many different ways in which the movement of projectiles can be done. You could use physics on your projectiles, but what if you want thousands upon thousands of projectiles to be simulated? That is where Unity's physics may not be the most reliable performance-wise, and this is where Bezier curves come into play. So getting right into it, in your scripts folder, create a new C# script called quadratic curve. The reason why it is called quadratic curve is because the type of Bezier curve we will be using is a Bezier curve with only one control point. Now create a game object called curve, and 3 new game objects called A, B, and control. Now attach the quadratic curve object on the curve game object, and open up Visual Studio. Now in Visual Studio, create these variables. Each of these variables are merely references to the transforms of the A, B, and control game objects made earlier. Now create a new function called onDrawGizmos. This function will allow us to draw primitive graphics to visualize our Bezier curve. Next up, we will now start making the Bezier curve logic. Create a function that returns a vector3 called evaluate, and have it take in a float called t. Now in the evaluate function, create 2 local vector3 variables. The first one is the interpolation from point A to the control point, and the second one is the interpolation from the control point to point B. Lastly, create a return statement, which is the linear interpolation from the first vector3 variable made to the second variable made. In other words, the interpolation of the interpolation. Now the functionality for the curve is complete. To be able to visualize this, back in the onDrawGizmos function we created earlier, add in an if statement checking if any of the transform references created earlier are null or not. This will prevent any null reference exceptions from being thrown when in the editor. Now create a for loop that evaluates the Bezier curve at different points in time from 0 to 1, so we can visualize the curve in the editor. With those lines complete, the quadratic Bezier curve is complete. Now in the editor, if we assign the transforms we created earlier on the quadratic curve script on the curve object, and we move our points around, you can see the curve come into form. Now let's add in a projectile behavior that follows this path. Thanks to how we made the curve, this part is really simple. All that needs to be done is have a separate script that stores a reference to an instance of a quadratic curve, and over time sets its transform position to be various evaluation points sampled from 0 to 1 using a float that is increased by delta time multiplied by a speed variable. The rotation is also handled by getting the difference between 2 points on the curve that are very close together. With this script attached to a cube object and assigned a speed and a curve instance it will adhere to, upon pressing play, the cube will follow the path, and when reaching the end point, it will destroy and debug that it has boom blam explosion kadooshed. And that is pathing projectile motion without physics in Unity. That is all for this video. For more tutorials on C# and Unity, like, subscribe, and I hope to see you all in the next video. Goodbye.